Before we could change the world, we had to start somewhere. Kenya. To start, we had to gain an understanding of the area. Enter Gilbert, our project advisor and Kenyan native.
My name is Gilbert Nalelia. I come from Kapenguria, Kenya. Kapenguria is located 20 kilometers from Kitale. Kitale is in the northwestern part of Kenya. I graduated from high school in 1998, and I was lucky to get a scholarship to go and study in Krakow, Poland. I did my undergraduate and graduate degree in electronics and telecommunications at Krakow University of Science and Technology. When I graduated from Krakow University of Science and Technology, I moved to the United States, specifically to Gonzaga University in the state of Washington. And in Gonzaga University, I took some classes in environmental engineering and some classes in business management. I was also involved in teaching a lab in environmental engineering. All these classes were in preparation for coming back to Kenya and to run and manage a Filtron manufacturing plant, which we were planning to set up in Kitale, Kenya. After traveling to Poland and the US, and after seeing the development in those countries, and comparing the development in those countries and to Kenya, I realized that Kenya suffers from underdevelopment and overpopulation in the major cities.
In the last 50 years, Kenya has grown from 7 million to 37 million people. Only 20% of the land is arable. The population increase has put a strain on all resources.
Kenya, being located in sub-Saharan Africa, experiences a lot of water issues, and some of these water issues are municipal systems which are extremely unreliable. And when we talk about municipal systems, not all municipal systems reach the villages, and therefore people in the villages have to go and fetch their water from the lakes and from the rivers and just from ponds. And you can imagine just any surface runoff water is always contaminated. Just having the fact that in most sub-Saharan African countries, we also have underdeveloped sewer systems. Therefore, most of the water that you find from the rivers or from the lakes or from the ponds are always contaminated. Some other issues that are also related with water is people have private wells. And these wells are not always filled with water, especially during the dry season, because during the dry season there is no rain, so the amount of the water in the wells declines. And depending on the location of the wells, you might find some wells drying up and some not drying up. Kenya experiences about 45 inches of rain per year, but most of this rain is experienced between the months of March and August. Most of the wells dry during the months of November, December, and January. And that is because during those months we don't experience any drop of rain. Looking at all the water issues, we can come to a final conclusion that there is just not enough clean water.
Rainwater harvesting has been used for thousands of years. It's as simple as throwing a bucket out in the rain or using a roof as a catchment area into a gutter system and then into a storage tank. What the Gonzaga team did was design a simple, scalable way to create a rainwater harvesting system. We took the rainfall in Kenya and the area of the roof and designed and sized a gutter system and a storage tank to meet the needs of, say, a single family, or if needed, a larger population, such as a school. There are many material options for rainwater harvesting systems, making it easily adaptable all over the world. The main advantage of using rainwater collection is that it brings a reliable water source to the site. This is especially important in Kenya because Kenya experiences about 3 months of drought. With this system, they can store water through the rainy season to last them through those dry months. Now, technically this water is not potable, but it can be directly used for, say, irrigation or water features in the home, and can be filtered for drinking water.
Because of water issues in Kenya, we need a way to clean the water from different sources. And these sources are lakes, rivers, rain harvesting. Filtrons, which are ceramic water pots, are already being used in West Africa, and we want to implement them in Kenya as well.
Filtrons are made from a mixture of local clay, water, and sawdust. The mixture is then pressed into a mold, shaped like a flower pot, and fired in a kiln. While in the kiln, the sawdust is burned off, leaving holes big enough for water molecules to pass through, but small enough to stop most pathogens and viruses. The inside of the filter is also coated with a layer of colloidal silver that prevents the buildup of bacteria. Each batch of filters is tested for effectiveness in removing impurities such as fecal matter and E. coli. Filtrons can filter about 1 to 2 liters of water per hour. One filter can provide enough potable water for the average household in Kenya. Filtrons will last a lifetime, but need to be cleaned and recoated with colloidal silver about every 2 years. %70 of the electricity in Kenya is produced by hydropower. This source is completely dependent on the rainy season. 80% of the people in Kenya live off the power grid due to their remote locations. Of the 20% that have access to power, most are not guaranteed consistent electricity.
Power in Kenya is not very reliable. I can remember when I was a young boy growing up in Kapenguria, Kenya, we were not connected to the electrical system. So basically what we used were car batteries. And at times I remember my dad traveling from Kapenguria to Kitale, which is 20 kilometers away, to recharge those car batteries and to bring them back home. And we mostly use the car batteries for lighting and for running devices, electronic devices like a radio or a TV. So you can imagine somebody traveling from Kapenguria to Kitale, which is about 20 kilometers, just to recharge the batteries. It's a long way.
Rather than relying on the national power grid, people can use car batteries. The question is, how can we charge the batteries sustainably?
Well, we're here at St. John Bosco Children's Center in Kitale, Kenya. And we're in this area of the country, like so many areas, we're not yet connected to the electrical grid. Electricity probably reaches about 20% of Kenya, and the other 80% have to come up with some kind of alternative. So here at St. John Bosco, we operate off of solar panel. We have 6 panels on our various buildings, and that's sufficient for us. There are 60-watt panels, and in one case an 80-watt panel. The panels are enough to provide fluorescent lighting for the children's dormitories in the evening, for their dining hall in the evening, and also their recreation room in the evening. I'm also able to run a computer to do all of our administrative work through one of the solar panels. Lastly, we like to be able to show children's videos to the children and also certain educational videos, and we can run a TV for a couple hours in the evening off of a 60-watt solar panel. The one issue for Kenyans in general with solar panel is the cost. It maybe costs around $1,000 for each panel, battery, all the apparatus that goes with it and the installation of it. And that's certainly well beyond the means of most Kenyans. So for most Kenyans, as far as their electrical needs, they're either using a battery that they charge, or they are waiting and hoping for the electrical grid, the power grid in the country, the infrastructure of the country to expand to where more people can have service.
The Gonzaga design team has come up with a wind alternative to charging the batteries that families already use in their homes for electricity. This alternative is a Savonius rotor windmill, which is a vertical axis windmill as opposed to the typical horizontal axis windmills most people know. The Savonius rotor has two main benefits. First, it is very effective at low wind speeds. And second, its simple blade design makes it very cheap and easy to make. You can make it out of 55-gallon drums, a bicycle wheel, and automotive alternator to produce the power. This whole system should be able to be purchased and made with under $200.
Charcoal is the main source of cooking fuel in Kenya. It is also used to fire masonry and the ceramic water filters. Because of the high demand on charcoal, deforestation is a major issue. Before the population growth, Kenya's forests covered 10% of the land. Today, it is estimated that only 1% of Kenya remains forested. This deforestation is leading to the rising cost of fuel.
Charcoal and firewood are the most common fuel sources in Kenya. Most of the foodstuff in Kenya are prepared from boiling or from boiled water. An example is ugali, tea, or stew. I can remember when I was growing up, my mom used mostly charcoal to prepare food. And she also used charcoal to boil water for cleaning and for also bathing. I would say that charcoal and firewood were the only available fuel sources for cooking and for cleaning.
After recognizing that boiling water is a large staple in the Kenyan home, we've developed a simple solar alternative to boiling water. By using solar concentration, simple fluid principles, and thermal insulation, a family is able to have up to 5 gallons of boiling water at the end of each day using this method. While this won't completely eliminate the need for charcoal in the home, it will greatly reduce the amount needed. If a family uses this method, they can not only save money on charcoal needed, but they can also help to offset the increasing rate of deforestation in the region.
Growing up in a farming community, my dad owned a 20-acre farm where we planted corn. At the end of the year, when we harvested our corn, we were supposed to sell the corn to the National Cereals and Produce Board. But before you could sell your corn, you had to dry your corn to a certain moisture content. And there are so many issues related with drying the corn to that particular moisture content. Because from a 20-acre farm, you would have maybe 290 kilogram bags of corn. And the way we used to dry it was just put the corn kernels on top to dry to the right moisture content. And you can imagine spreading 200 sacks of corn on a top. They're prone to a number of things. First of all, theft. Second is just spoilage. Third is animals feeding on your corn kernels when they are drying on the top. So we used to make sure that there was somebody to watch on the corn when it's drying up. And you can also imagine in the middle of drying, if all of a sudden it starts raining, you can lose everything. So it was a very tedious job trying to make sure that you dry the corn to the right moisture content to be able to sell it to the National Cereals and Produce Board.
Well, here we are at the Maji water filter site, And as you can see, they grow a lot of corn in the region, which is why our agricultural solution focused primarily on maize production. We wanted to not only improve efficiency by introducing and catering some U.S. methods here to the Kitale farmers, but also, more importantly, we wanted to provide an economic stimulus, which would allow the successful implementation of the other 3 products we proposed. Our solution was a wind-driven grain drying and storage system, which would allow farmers to safely store and dry their maize crop immediately after harvest, reducing losses due to theft, foraging animals, and spoilage out in the field. But also, the new ability for safe long-term storage will provide a market advantage when it comes time to sell the grain. And after research, we found that here in Kenya, that equates to about a 30% increase in sale price. And for the average Kitale farmer operating on a 5-acre plot of land, that 30% increase will not only provide enough money to pay off the system within the first year, but also leave some extra money for the this purchase of, say, a water heater or a windmill or rain catchment system.
With local support, we were able to get the funding to fly to Kitale, Kenya. While in Africa, we had a few goals. First, we wanted to assess the viability of our alternative technologies. And second, we wanted to help with the construction of a water filter manufacturing facility. Our trip and the facility were both sponsored mostly by SWEF, Small World Education Foundation. SWEF is a non-profit organization based out of Spokane. The founder of SWEF coordinated the construction of the manufacturing facility and was able to join us on our trip.
We started SWEF, I say we, my wife and I, Connie, we started SWEF about 10 years ago after a simple tourist trip to Kenya. On the way home on the plane, we were discussing how much Kenya needed in every area, but specifically the educational area. We'd visited a small school and realized it was just dirt poor. The result was that we invented SWEF, Small World Education Foundation, with the primary goal of bringing books into Kenya, into the rural schools. That has morphed since then to several disciplines which all fall under the category, what can we do to help Kenyans? Solar power systems, medical supplies, simple water delivery systems. They all fall into that category. And about a year and a half ago, I read an article in the Spokesman Review, the Spokane Spokesman Review, which talked about Gonzaga inventing water filters. I got hold of Dr. Brad Stribig in the engineering department, and he corrected the article. No, we didn't invent the filters, but we know about them and we wanted to perfect them. I learned about the filters from Brad Stribig. I went down to Nicaragua and met with a fella down there who's kind of the father of this Filtron filter, and came back deciding that this is something that will work in Kenya. I approached Gonzaga and got some support from Gonzaga, specifically the School of Business. They, in conjunction with Gilbert Malalia, wrote a business plan that won first place in a Washington State competition for business plans. It's a Kenya-centric business plan to run a water filter company. I then approached Rotary. I'm a Rotarian in Spokane. I approached Rotary for funding. Bottom line is we have funding through Rotary International. We're working in conjunction with a Rotary Club here in Kenya, and we're off doing a water filter project. Another very key player in this is the Bishop of Kitale, Bishop Morris Crowley. We're at Bishop Crowley's home right now. He's very supportive of this. And so we're going to build a filter manufacturing site here in Kitale. We started, not students, but new graduate engineers have been very helpful in this effort, and we're moving right along. I wish we were moving faster. unfortunately, you've only been here about 2.5 weeks, and we're just at the point where we're going to place our containers on the ground and build the structure under which the filter manufacturing facility will find itself. We still have to build a kiln. We need to dig a well. We need a source of water to mix clay. We would have to build a latrine because that's one of the health requirements. We will get this up and running, and we will prevent little kids, 5-year-old kids and younger, from dying of the ravages of diarrhea and dysentery, which leads to death for young kids.
Welcome to the Maji filter site. We're here on our 10th day of work. Things are moving along pretty nicely. Behind me here we're pouring the concrete slab. This will serve as the working surface or the factory floor for the filter production. On either side of which we have 6 column footings. You can see here. On these footings we'll place our 2 shipping containers once they arrive here from the port of Mombasa. Inside those containers we have the donated makings of a metal pole building. When they arrive, we're going to stand some steel columns and stretch some beams and purlins and deck the roof. This will provide us a shaded, rainproof working surface for the filter production. And once empty, the containers will provide safe overnight storage for both equipment as well as finished product. Construction's been a little bit slow. Due to some of the primitive methods over here, due to the lack of equipment and machinery. You can see here to my left we have our concrete mixing operation. Everything's been done here on site with the use of a shovel and some wheelbarrows. Also, about half of the timbers used in the formwork were all harvested and cut to size from trees here on site. The gravel used in the footings was crushed all by hand using this large hammer from the boulders you see here to my left. Additionally, we have had trouble finding a reliable source of water. We've run one well dry mixing concrete, and we've had to resort to hiring a mule-drawn cart to fetch water from a nearby pond nearly 3 kilometers down the road. Next step, though, is we're going to dig a well as well as a latrine and construct a kiln for the actual firing of the pots. We're confident that if things continue as is, we'll see this plant fully operational here in a couple months. At which point we'll turn over the day-to-day business operations to the capable hands of Gilbert Nalalia.
The 2 major goals of these projects were, firstly, to make sure that the Filton manufacturing plant is up and running. Secondly, to come up with a way of distributing this technologies that this senior design team has worked for 1 year. And the solution to the second kind of a problem is to build an educational facility where the locals can come and learn about these technologies and go back to their communities or villages and implement these technologies. And I'd like to point out that this educational facility will be running on these 4 technologies, or some of these technologies. And the development of this educational facility can be undertaken as a senior design team by future Gonzaga students.
I'm here at the Challenge Farm with my friend Jan. Hey Jan, say hi.
Hi,
It's recording.
it is recording.
It is. Thanks for showing me around today.
Yes,
And next time I come, we're gonna have ugali, right?
yes,
We're gonna eat some ugali together, and maybe work in the shamba.
mm-hmm.
Is that right?
yes.
Okay. Now your turn. You guys say.
Challenge farm.
Yeah.
Hi, I am coming next time. When you come, I am teaching you Kiswahili.
All right.
Bye.
See ya.